any others? Just the two of you? All right. Two groups.
Oh.
Okay. So let's start with Nini. Give me the first three. Okay. 1,000,001. So 1, comma 000, comma 001. Yes. All right. Give me two more. 10,001. 10,000. Everybody else should be filling these in. And if somebody makes a mistake, we'll fix it later. 100. Okay. Edwin, give me the next two. Yes, sir. Yeah. And no, think so. Positive 1. What's one time? That's also 2. All right, and the last three. 101. Keep going. 10,001. Ooh, stereo. Go ahead. 1,000,001. Ooh. We should already start seeing some patterns. We're not going to talk about them just yet. Okay. 1,000,001. Okay. Where are my cubics? 30 degrees. One over here. Camilla, give me the first two.
negative 999 million.
Oopsies. Sorry.
Wait, just
negative. I'm just having issues right now. Negative 999 million.
999,000.
Okay. Next one.
999 million. I mean, thousands and 999.
So one more time.
999.
Positive or negative?
Negative.
Negative 999, comma 999.
Yes. And then negative 999.
Negative 999.
Yeah.
Where are my other cubics? Okay, come on, give me next two. 0. Okay. Come on now. 0. 2. Ooh, look, same as that one. Desmond. Give me next three. 1,001. 1,000. Okay, keep going. 10,001. And then 100,001. Okay. 100,001. All right. So now I have a question. I'm looking at my squared, and I'm looking at my cubed, and I got the same number. One of these has to be incorrect.
It's 1,000,001.
Yeah. So over here, if I'm taking 100 to the third power, I just have to count zeros. 2 zeros times the third power gives me 6 zeros. So I'm missing some zeros here. So one more time, Eduardo. 1,000,001. So 1, comma 0, 0, 1. Okay. So it's increased in an order of magnitude by another 3. So then, Eduardo, what's this last one going to be?
10 billion.
10 billion. So 10, comma, don't need that one. 10 billion 1?
Yeah.
I need a couple more zeros. Okay. So 1,000 to the third power. So I got 3 zeros times 3 gives me 9 zeros. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So I think we might be off by just a little bit. So instead of 10 billion, how about 1 billion? Okay. Because I got 1,000 to the third power gives me a billion. Because 1,000 thousands is a million. And then 1,000 millions is a billion. Billion. 1,000 millions is a billion. Every time I add 3, just adding 3 more zeros. Okay. All right, where's my fourth degrees? All right, William, give me the first couple.
1 trillion.
1 trillion. So that's a lot of zeros. How many zeros is that, William? 12. 1, 2, 3, 4, 5, 6, 7, 8, 9. Our last one should be a 1. Okay. So we got 1 trillion and 1. Whoopsies. Keep going, William. 100 million 1. 100 million 1. All right, Franklin, give me the next two.
Next two.
Either.
Okay. 10,001.
10,001. 10,001. Hey, we had that down here. Interesting. Okay, keep going.
2.
2. Okay. One more.
2.
2. Okay. Where are my other fourth degrees? Over here. Ashley, give me next 3. We got 2. How many 1? 10,001. Okay, keep going. Oopsies.
Seven zeros in the next one.
7 zeros. Okay. 1, 2, 3, 4, 5, 6. So 1 million. That might be off by a little bit. Oh no, that's okay. So I think I'm missing some stuff. There we go. Papa Dapa. 100 million and 1. So are we starting to see some symmetry good here? Franklin. You okay? Franklin?
Oh, yeah.
Okay. All right. So can we copy and paste this one? Can we see some symmetry here? We should see some symmetry. Talked a little bit about this before. And this last one, you need lots of space here. Okay. So shove your thing off to the side. Wrong way. That way. Where's my 5th degrees?
Right here.
All right. Give me the first 3, Jamie.
I don't know what number that is, but it is
Positive or negative? Start with there.
negative,
Negative.
and then 15
15
zeros.
15 zeros?
14 zeros, no one.
That's what I got.
Where am I in the 5th degrees?
Oh, right. Yes, we I also put 15.
15 zeros?
Yeah.
15 zeros? But then what are we doing? We're subtracting 1. Okay.
Oh.
We're actually adding 1.
So it's like
So it's going to be very similar to this one, but instead of 9 nines, how many 9s you got? Okay. 1, 2, 3. 1, 2, 3. 1, 2, 3. 15 nines. 1, 2, 3. 1, 2, 3. Okay. Because I have, let's see, so hundreds, thousands, millions, billions, trillions. Anybody know what comes after trillions? Quadrillions. So we had 1 quadrillion, negative 1 quadrillion. We add 1, and we're back into the trillion. So negative 999 trillion 999 billion 999 million 999,000 999. Okay. Can we see what's going on here? A little bit. If you can't, that's okay. We'll formalize it in a couple minutes. So the next one, what's my next one going to be?
Would it be 12 nines?
Going to be 12 nines. Okay, so negative. Actually, not 12. I think we're only looking at 10. Because we have 100 to the 5th power gives me negative 10 million, or billion, excuse me, and then we're adding 1. So negative 9,999,999,999. Okay. Okay, they get smaller. Can we just figure out that we don't have any 1s and 0s? They're all 9s. Okay, so let's see. We took away. That one has 7. That one had 7. So this one's going to have 5. So negative 99,000. 999. Except for this one. We don't have 1s. We don't have 9s. It's got plain old ordinary little 0. Okay, because negative 1 to the 5th power is negative 1. And negative 1 plus 1 is 0. Okay. So positive 1 to the 1/5 power is 1. 1 plus 1 is, ooh, look, they all have the same amount. Okay. And then kind of similar up here, Now we flip-flop. No more 9s. All 1s and 0s. So we had 100,000. Now we're adding 1. 100,000. Add 1. We have 10 billion. We add 1. So 10 billion. Add 1. Last one. We have 1 quadrillion and 1. Come on now. Come on. There we go. 1 and trillions. Oopsies. Billions. Millions. Thousands. And oopsies. Baba. Baba. Okay. Trends. What do you see? Franklin.
In the what? It's the third power and the fifth power. They're both have 0 and 2 in the middle.
Okay, we got 0 and 2 in the middle for the third power and the fifth power because my +1 counteracts my -1. Okay, and here it's always 1 plus 1, so it doesn't make a difference when it's positive. 1 to the fifth power, the third power, the fourth power. 1 to any power is 1, and 1 plus 1 is 2. Okay, what else? What other trends do you see?
All the odd ones, if you add 2 and then times by -1, you'll get the positive numbers on the bottom.
Okay, one more time. All the odd
degrees, so
Yeah.
3 and 5.
Yep.
If you add 2 and then multiply by -1, you get the bottom positive one.
Ooh. Okay. So I want to talk about that a little bit more in a minute. Okay. So the odd degrees. One more time. You do what?
You basically just multiply by -1 and add 2.
So multiply -999,999,999 and add 2 and you get the one on the bottom. Cool. All right. Any other trends? Look at the even degree ones. What do you notice don't exist there that the odd ones have?
0.
They're negatives. Okay. There are negatives here and here, but not here and here. Because a negative times a negative is positive. So if I have every time I have a pair of negatives, that gives me a positive. So if I have an even degree, I'm always going to be pairing up my negatives. Can't have any positive. I can't have any negatives then. Whereas if I have a negative to an odd degree, that's a negative because I got a pair or group of pairs. If I have negative or positive x to the 33rd power, my first 32 x's give me a positive, but that 33rd one changes it to negative. So this is what we're going to talk about today. This is called end behavior. So illustrative math talks about it in general terms. We're going to formalize the definition, but we're not going to use fancy words just yet. So let's make a little text box right above here. Let's talk about what end behavior is. Okay, end behavior is what happens to the graph is not right, as your input values move far away from 0. Okay. So my input values are my x's. So what does x measure when I move in which direction? Horizontally. So we have 2 directions, right? We have to the left and to the right. So for end behavior, we have what's called left end behavior. And that's what happens when x is arch in the negative direction. And we have right end behavior. And since it's almost the same but opposite, can we copy and paste? Sure. So just take that second row. Well, Control C, go to the end. Control V, change left to right. And change negative to positive. Okay? All right. So just for your polynomial, I want you to sketch your graph So you can use your shapes tool. Let's make a set of axes. Hold the shift key down. Make a horizontal and vertical. Then go to the drawing tool. I would use a thickness of 1. And just make a really rough sketch of your graph. And then now go back to Desmos and plug in the polynomial and see what it looks like. See if your sketch was right. Okay. We're not going to sketch all of them. I just want you to sketch your own. And then we're going to talk about end behavior in general of the polynomials that we chose. Make a sketch and check it in Desmos. So I am going to do sketches based on information that you tell me what to do. So I'm going to make a rough sketch. Where are my second degreeers? 1 and 2. Okay. Where should I start? Which quadrant?
Quadrant 1.
Okay. And what should I do in quadrant 1? Should I start down here or up here?
Up there.
Now what?
Down.
Down.
Now, wait, stop at 0.
Stop at 0. Did it hit 0?
No, that's
So just a little higher. Okay. So it's going to come down. Just kind of miss the 0, and then what? And then go up. That's all. So let's talk about this. On the left-hand side, it's going up, and on the right-hand side, it's going up. Where are my fourth degreeers? What happened with the fourth degree? So kind of like this one, right? Except the only difference with the fourth degree, it's going to go up faster. So instead of like this, maybe it's more like this. These are real rough sketches, right? Super rough. Okay? So let's talk about it. So go to your text box. And as we go left, it goes up. As we go right, it goes up. Both sides, it's going up. It's already kind of established. Whether it's positive or it's negative, I would take it to an even degree. I'm going to be looking at pairs. If I have pairs of negatives or pairs of positives, it's always going to be positive. And then I'm adding a 1 to it. So that's why it never crosses the axis. But we're really only focused on the areas on the left, far right, far left. Okay. All right. I have to carefully erase. Okay. My odds. Where are my odd folks? Well, I know most of you are odd. Odd degree. Give me odd degree. Odd degree. Marcus, you guys were odd? Yeah. Okay. So where should I start? Which quadrant? First, second, third, fourth. Third? Okay. Should I start close to the axis or way down? Way down. Okay. So now what? Where am I heading? To 0? So this one crosses. And then what? Whee! Okay, fifth degree. Here's my fifth degree.
All right here.
Right here. Does it look different than that? Except maybe starts a little closer to the axis. Maybe flattens out a little bit and then goes up. But my end behavior is the same. Go back to your text box. Tap, 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 tap. So as we go left, it's not going up, it's going down. Okay? Tap, 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 tap. As we go right, it goes up. And that is end behavior in a nutshell. That's it. That is the long and short of it. Now, we're going to convert our English into math. Illustrative math does not do this. This is visual, so you're going to actually have to look up here. Chris, there we go. Okay, so we're going to rewrite these. So I'm going to take my text box. I'm going to scoot it over just a hair. Okay? And right next to it, I'm going to put an equation box. So, as we go left, this is how we're going to write this. So the equivalent of as we move left. So left is my x values. And what we're saying is we're approaching a really big negative. What is the biggest negative you can think of that's really a concept and not a number? Infinity. So the way we say approaches, ready? Click on the little pi symbol. And what we're looking for is an arrow. You guys see the arrow?
Yeah.
fifth row, first column. And we're approaching negative infinity, which is second row, first column. So here is this part. As we go left, that's what this means. So the words left means that, okay? Back to your equation box, put a little comma action in there. Which way we going? We're going up. And that's my y value. So y also approaches. And the nice thing about Cami, I just used that arrow. So anything I use recently is going to be on that top row. So up would be approaching infinity. It is understood that when I put infinity, it is positive. So that's my left end behavior. So if you want to, you could either like pull a little circle. This is my left end behavior. Okay? Now I need my right end behavior. So right below that, another text box. So x approaches, well, if I'm going to the right, that's not negative infinity, that is positive infinity, comma. Is y going down? No, it's still going up. Okay, so y approaches positive infinity. And this is my right behavior for my even degree polynomials. Okay, I want you to take a moment and see if you can figure out, whoopsies. There we go. What your odd degree polynomial end behavior looks like. Not going to look that different than these. So take a minute, see what you can figure out on your own using the words from the text box. So x should approach negative infinity. So that part's going to be the same. Just to keep things simple, I'm just going to copy this whole thing. So a little Control A, Control C, Control V. But in this case, on the left-hand side, I'm not going up, I'm going down. So put a negative there. Okay? So I'm going to be a little bit more precise here. I am going to erase this, and it actually connects to this piece right here. I'm going to erase this, and it connects to this piece right here. Okay? So let's go different color. Let's go pink. So on my left-hand side, it goes down. On my right-hand side, it goes up. So it's really the same as this one. Okay? So a little Control A, Control C, and on this one, I don't have to change a dang thing. This one exactly works. Hello. Okay. And that is end behavior. That's it. So in English, this one says, as I move left, it goes up. Because anything with even, up. As I go right, it goes up. So the even ones, up on both ends. But the odd ones, I told you I was reliving junior high school. Oh, you wait. We're not done yet. Okay? All right. Oh, no. I didn't want to do that. Okay. Mai's back. Yay. Mai is studying the function negative 1/100th x cubed plus 25,422 x squared plus 8x plus 26. She makes a table of values. Ding. She thinks that this function has a large positive output values in both directions. Have a little conversation with the people around you and either agree or disagree, and then I will give you a visual representation that unfortunately will not be shared here in our screencast because I don't have a webcam on. You'll see. All right. So have that conversation. Is she right or not? If she's wrong, then explain why. Is that your mom's name?
Yeah, it is. It's a legal name too.
So, Outputs in both directions. Where should I look to determine if mine is correct or not? What have we been talking about? Function-wise. Focus on the exponent. Which exponent? Because I see two of them. The leading term's exponent. Okay? Told you. Getting ready. So, with our original x cubed, it was down here and down here. But with mice, what's in front of the x cubed? A negative. You ready? When you have a negative, my negatives become positives and my positives become negatives.
Wait, can you repeat that?
I got a negative coefficient here, yes? So originally, my x cubed and my x fifth look this way. Because on the left-hand side is down, right-hand side is up. But when I make a negative, what happens to my y values? They switch. So your positive coefficient, x cubed, this way. Negative, it doesn't make a difference how small it is. It's still this way. Okay? So positive, cubed, fifth, seventh power. Negative, cubed, fifth, seventh, ninth, 33rd, 301st power. So she's wrong. Not even because the 1/100th. All about the negative. What happens to these coefficients and the numbers in general when it gets really large? What kind of effect does it have on the graph? It has no effect at all. Okay. What takes precedence when I'm looking at an equation? The exponents. The bigger the exponent, the more influence it has on the number. So even though that's negative 1/100th, if I'm talking about 100,000 to the third power and then I multiply it by negative 1/100th, that's not going to change it much. The significant change is it was positive, but now it's negative and vice versa. Okay? Oh, we're all going to do it in a minute. Oh, yeah.
Oh, no.
All right, here we go. So let's just take a brief look at this. And the easiest way to look at this is in decimals. Okay? So I am going to rewrite my equation. 2x to the fifth minus 5x to the fourth minus 30x cubed plus 5x squared plus 88x and then plus 60. Okay? All right. So there's a couple different ways you can look at this. But I got 4 numbers to plug in. And I've got 1, 2, 3, 4, 5 places to put it. What tool really lends itself well to plugging in different numbers into the same things over and over and over again? What part of Desmos? A table. So let's go to Desmos. And let's get away from the scientific calculator. And let's go to the graphing calculator. And what we're going to do is we're going to take each of these terms and cut them up. So let's make a table. We're putting in the numbers 0, 1, 3, 5. And then up here, we're changing these to, first term was 2x to the fifth. Since I'm making a table, it can't just be 2x. Watch what happens when I do 2x. Oh, look, it's saying, hey, too many variables, try defining x. Well, I've already defined x over here. X is x1, so this also has to be x1. If I just put a 1 next to it, and then shift to the fifth power, okay? Because 0 to the fifth power is not very big. 1 to the fifth power is not very big, and then multiply by 2. And then we just make a new column. Ready? Go to the right. Boom. Once. Boom. Twice. Oops, too many. So now my next one is negative 5x to the fourth. Negative 5x1 to the fourth. And I'm going to keep going to the right. I'm going to need lots of space. Let's move this over here. I don't really care about the graphs. And my next term was negative 30x1 shift to the third power. And my next one was positive 5x squared. I don't need the positive. 5x1 squared. And my last two are 88x1. And my last number is 60. If you don't have this all in there, don't sweat it. Okay? It's okay. Don't worry about it. Because what I'm really interested in is where these are the largest, at what place. So in x is equal to 60. What's the biggest number you see on that row? 60. So 60 would be my highest term for 0. Okay? When I look at 1, what's my biggest number? 88. When I'm looking at 3, what's my biggest number? Okay, 486. Okay, isn't it? And then my last number?
6,250.
Okay, that's it. Okay, so what happens as I go further and further down here? Say I put the number 300 or 500 or 1,000. What does the negative 5x to the fourth minus 30x cubed plus 5x squared plus 88x plus 60 do to the problem? Basically, nothing. Because these numbers get so big, the rest of these have no influence whatsoever. So what has the biggest influence?
The exponent.
The exponent. Okay. So, what's the end behavior of this one going to be? Oh, erase. E. Ooh, clear. All right. Back here. How are we doing? Okay. So, as we go to the left, so x approaches negative infinity. Is it going up or is it going down? It's going down because I got a negative number to an odd power, and my coefficient is positive. So, comma, y approaches down, so that's negative infinity. Okay, so that is my left end behavior. You want to put a little text box in front of it, say left, that's just fine. Right? Do a little Control A, Control C. What do I need to change? First of all, I'm going right, so is it negative? Okay, and then I have a positive number to an exponent, so it's going up, which is also positive. So both of these negatives should be positive. Okay. Here's the great news about end behavior. Okay, with polynomials, there's only 4 options. Okay, we haven't even talked about the other ones. Okay, we've only done up, up. We've done down, up. We've done up, down. What's the last one? Down, down. Okay, how would you make a down, down? The degree has to be positive or odd or even. If it's down, down, it's got to be even. So squared, fourth, but then what has to be in front of the leading term? A negative. That's it. That is it. Okay. So I guess we'll have to save the dances. Well, I'll give you guys an option. We could either do the dances, or you could do the cool down. I'll give you the option. Which one? Dance. Okay. All right. So stand up. If you want to work on the cool down, you work on the cool down. Okay. So, does nobody wants to do it? He was going to do it, and then do the peer pressure. Fine, do the cool down. Cool down.
You can do it. You can go ahead.
Cool down. Okay, we'll do it tomorrow.
Oh, get over with.
As you can. Cool down. Cool down. 3 minutes. Only one problem.
It's embarrassing if everyone does it.
Only one problem.
If everyone does it, then it's not embarrassing. It's fine.
So if you're having trouble with the symbols, then just write it out in words. For the cool down, you could say, as input gets large in negative direction, what happens to the output?
Kids are saying, shit.
Language.
I don't understand this, bro.
Now, cool down's a little tricky because your first term is not your leading term. It's the second one. You're looking for the highest exponent. There you go. That's what you like.
Yeah, the Wi-Fi's like really messed up.
So this is short, right? So before you turn it in, make sure you did it.
What is this supposed to mean? Yeah, I understand.
You're on the soccer team? Yeah, what last year?
It's a 20-minute walk. I can't say
I did bitches last year. I had classes with what is his name? Jagger. That was so sad. He was so rude to me in physics, and now he's like switching it up. He's like,
Bro, I wonder if they hate him. Martita.
It was me.
I think he doesn't like it.
My face. Hi.
I'm not joking.
You're such a nerd.
You made it.
I'll throw it away. But okay. You just after your own mess.
I can tell you, but I don't know myself.
Exactly. So who's that?
You?
It's yours. Yes, my favorite pencil. Go steal it.
Right.
Yes. Yes.